Hello everyone. During this video I'm going to recap how to use the cast diagram to solve trigonometric equations, whether that's using degrees or radians. So during this video I will do both. First of all, a quick recap. Cast diagram, we start off with the C, A, S and T. That is how we spell cast, always in that section. This section is 0 degrees, we always measure from here. So if we turn, so when we get to this line, that is 180 degrees. And if we turn again, that is in 360. Each of these tells us where positive signs go. So no matter what equation, whether we use sine, cos or tan, all of them are positive in that section. Only sine is positive in this section. Only tangent is positive here. And only cosine is positive here. Using this, we're going to go through how to solve using a cast diagram. So first of all, the first 3 examples are just a reminder of how to use it. So from here, we've got 3 equations. We're going to start with the top one. Sine x equals 0.25. So the first thing I do is I solve for x. So I'm just going to check. I have a D at the top of my calculator, so I'm in degrees mode. So 0.25. The inverse sine of 0.25 is 14.5. So I can see here x is 14.5. Sorry, this should have said 360 degrees. I'm just going to correct that there. Okay, so from here, I now draw my cast diagram. So I put my cross there. I only need to label up the x-axis. So 0, 180, and 360. I will never label up the y-axis. I'm looking at sine, so when I write cast, C-A-S-T, I'm dealing with sine, so all of them are positive here, and only sine is positive here, so this tells me the positives at the top. And I put 2 minuses in the other section. I now look at this angle. This is a positive angle, okay? So if the angle is positive, we draw that in the positive sections. And angles are always drawn from the x-axis. So that means in the positive section here, that this is 14.5. I'm just going to do that in pen so you can see it more clearly. And we do one from here, also in the positive section. 14.5 and 14.5. So now measuring from 0, I'm going to go between 0 and 360, so I'm only going to spin once. So from 0 to there, I have gone 14.5 degrees. It's always worth checking because the answer here is not always one of your final answers. And then again from 0, how far have I turned when I get to here? So if I turn all the way to there, it's 180, but I need to go back 14.5 degrees. So my second solution is doing 180 minus 14.5. So my 2 solutions are 14.5 and 165.5 degrees. All right, let's have a look at another one. Again, this is staying in degrees for this section. So the first thing I'm going to do is the inverse tan of minus 0.3. And I get a negative angle. That's not a problem because we know how to use the cast diagram. So always draw your cross, label the x-axis. Now, for tan, well, they're all positive in this section and tan is positive here. So these two are minus. The angle we received this time was a negative angle. The negative just tells me which section I draw this in. So minus 16.5, there's the x-axis. There is one there. And I always measure from the x-axis. And notice this time I've drawn them in the negative sections. When I label them, I don't write minus on there. The minus is just telling me where to draw them. I don't actually label them negative here because the negative is there in the sections. So starting at 0 degrees, how far have I turned? Well, that would be 180, and we have to go back 16.7. So I'm going to do 180, take away 16.7, which gives me 163.3 degrees. So that is my first solution. So how far do I turn to get to this one? So I turn, well, if I turn all the way around, I get to 360, and I need to go back 16.7. So 360 take away 16.7 is 343.3 degrees. All right, let's do one more in degrees, then we're ready to move on to radians. Now, first of all, there's a number in front of my cos here. That's not good, so I'm going to divide both sides by 10 before I start. And now I'm going to do the inverse cos of minus 0.7. And we get 134.4 degrees. Do not worry about the fact it is obtuse. So I'm going to start off and label my x-axis. And I'll label cos. Now we're doing cos this time, plus, plus, minus, minus. I look at my angle. It is positive, so I draw this in the positive sections. And the great thing about cos diagram, you do not have to draw things to scale. So yes, I know that I've drawn an acute angle, and this is 134.4, but the thing about cos diagram, it does not matter. So I'm just going to draw that in the positive sections. So now I need to get my solutions. From 0, I've turned to here, 134.4. And then how far have I turned? Well, 360 will be all the way around. And then I need to go back 134.4 degrees. That's 225.8 degrees. And they are my two solutions. Okay, we are now ready to try one in radians. So this time I'm going to go between 0 and 2 pi. Now if you do remember, the key fact about radians is 2 pi radians is the same as 360 degrees, which means pi radians is equivalent to 180 degrees. So it's just worth remembering that. So just like last time, I'm going to just make sure, sorry, there is a little mistype here. This should read 14 just here. So sin x is 6 over 14. So apologies, there should be a 1 just there. Now, difference this time, I'm in radians. Now previously I had a d at the top. Before I do anything, I need to get into radian mode. So I'm going to do shift, menu to get to setup, angle unit is number 2, and click on 2 for radian. So now I should have a little r at the top. Whenever you use sine, cos or tan, you need to make sure whether you're in degrees mode or radian mode. So shift sine of 6 over 14 is 0. I go to 3 significant figures, so I'm going to go to 4, 4, 3. Okay, onto the cast diagram. Now notice I'm not actually going to do anything different here. I start off again with my cross. I label the x-axis, but instead of going 0, 180, 360, I'm going to go 0, pi, 2 pi. Cast, C-A-S-T. We're looking at sine, so we're positive in the all section and the sine section. I now look at my angle. The angle is positive. So it's drawn in the positive sections, measured from the x-axis. I will now get my solutions. First of all, from 0, I turn to here, which is 0.443. And then how far have I turned? Well, pi will get me there. So on my calculator, I'm going to do pi, take away 0.443, which is 2.3 significant figures, 2.70. And I'm only going to 2 pi, and there's no solutions at the bottom, so these are my two solutions. Now here are 4 for you to practice. I suggest you pause this video here and try and solve all 4, and when you're ready, press play and I will go through the answers. Right, first one. Cos theta, the 3 is in the wrong place, so I'm going to divide by 3. My calculator is still in radian mode, so shift cos 2/3 is 0.841. Into my class diagram, so I draw the cross, I label the x-axis. We're dealing with cos, which is positive here in all of them and here. The angle is positive. Now I just get my solutions. First one is 0 plus 0.841. And then how far do I turn from 0? So that'll be 2 pi, take away 0.841, which would give me to 3 significant figures 5.44. B. This time again, cos theta will become 5/7. Using my calculator, shift cos of 5/7 is 0.775. Again, positive angle. It's cos, so positive here and here, negative here and here. I draw my positive angle in the positive sections. So my solutions are 0.775, and from 0, how far do I turn? It would be 2 pi minus 0.775, and to 3 significant figures, that is 5.51. C. Tan theta would be 8/3. So on my calculator, the inverse tan of 8/3 is 1.21. So again, as always, I draw my cast, 0, pi, 2 pi. Tan is positive in all of them, and here, and negative in the other two. We have a positive angle, so I draw it in the positive sections. And then I get my solutions, 1.21. And how far have I travelled? Pi plus 1.21, so to 3 significant figures, 4.35. And lastly, D. All right, I've got to get this to say sine theta equals. So take the 5 onto the other side and then divide by 6. So as always, on my calculator, I'm still in radian mode, so the inverse sine of minus 5/6 is minus 0.985. I've got a negative angle this time. So positive in all and in sine, so the other two are negative. I've got a negative angle, so I draw this in the negative sections, but again notice I don't label the angle as negative, I just draw it in the negative sections. So my solutions will be, well, there's pi, so I've got to add pi, pi plus 0.985, which is 4.13. And then from 0, how far do I travel? 2 pi minus 0.985. And 2 pi minus 9, 0.985 is 5.30. Hopefully you got all those correct.